Okay, this is our last part of Chapter 1. We're looking at the second half of 1.6, and we're going to talk about absolute value inequalities. So remember I said before, and the reason why I split this up into two pieces, this section, is that compound inequalities, which is what we looked at in the first half of this section, the ands and the ors, are very much related to absolute value inequalities. In fact, they're basically another way to write the exact same thing. So the algebra in this section is not going to be any different than what we did in the last piece of section 1.6. It's just going to be more about understanding which absolute value inequalities look like ands and which ones look like ors. Okay, so I have some notes for that for you to fill in on your sheet, and here it is. So like I just said, absolute value inequalities are just compound inequalities in disguise. Okay, so if you see a less than inequality, we're really talking and. So if I said something like the absolute value of x is less than 4, that really means x is less than 4, and also x is greater than negative 4. And I'm going to talk about how you can go from an absolute to the two inequalities in a second, but that's the idea behind it. And then, or, if we see an absolute value greater than a number, that would mean an or inequality. So if I said the absolute value of x is, I wrote the wrong thing, is greater than 3, then we're really saying x can be bigger than 3 or x can be less than negative 3. And notice on the slide I have the equal bar. When I hand wrote it, I don't have it. Really, the equals or not equals doesn't matter whether it's and or. It's just whether it's less than is always and. Greater than always means or. Sometimes you'll get problems with the equal to bar. Sometimes you won't. You're really just looking at the actual inequality sign to tell you whether we're using and or. Okay, so we'll do a few examples of each, and then I'll let you go on some practice. So here's some less thans. Again, I have one that's less than or equal to, one that's strictly less than. Let me talk you through how to do this. So for our first problem from your notes, the absolute value of 7 minus 6x is less than or equal to 47. Okay, so like I said, it's a compound inequality in disguise. The inequality we're talking about, because it's less than, is and. So we're going to write two inequalities in a second, and we're going to combine them with the word and. The first inequality is exactly what the problem would say without the absolute value bars. Notice how that's a little familiar to us when we were doing absolute value equations. Remember the first equation we wrote was just what we saw in the problem? Okay. The second inequality, there's two things we have to change. The left-hand side stays exactly the same. The first change is the inequality symbol. So instead of a less than, now we have a greater than or equal to. The second thing we change is the sign of the right-hand side. So positive 47 becomes negative 47. Now we just solve. So we'll do the first one. We'll subtract 7 from both sides. We get 40. We're going to divide by negative 6. Remember our rule with negatives. So now we get x is greater than or equal to negative, I'm going to reduce the lowest terms, 20/3. All right, we'll do the same thing with the second problem, or the second half of this problem, rather. Subtract 7, divide by negative 6, but remember we're dividing by a negative. Becomes 9. Positive 9, less than or equal to positive 9. So our final answer is greater than or equal to negative 20/3, and also x is less than 9. So if we go to our trusty handy-dandy number line, we're going everything less than 9, but also greater than negative 20/3. Okay? Notice how we're really taking a lot of the different things we did in the last couple sections. The rewriting of two separate statements like we did with absolute value equations, the compound inequalities from section, well, the beginning of this section really, and we're making it into one problem. So really, algebraically speaking, nothing new here, just a lot more things being put together from this chapter. Basically putting everything we've learned in this chapter together into one concept. All right, let's look at another one. Okay, it's still going to be an and inequality because it's less than. The bar is insignificant. First thing I want to do, though, just like when we did absolute value equations, I want to isolate my absolute value symbol before I rewrite into a compound. So I'm going to multiply both sides by 10. Now the absolute value of 7 plus 4b is isolated. Okay, so now I'll write my two inequalities. First one is just what I saw. Second one, I keep the left-hand side the same. I flip my inequality, so now I have a greater than, and I make my 10 negative. And then I just solve. I'll subtract 7. Divide by 4, I get greater than 3/4. Subtract my 7, negative 17/4. So again, on my number line, I am shading everything from negative 17/4 to positive 3/4. But this is a strictly greater than and strictly less than inequality. So I'm not shading the endpoints. I'm putting my holes in there. Okay? That's less than. Now let's take a look at greater than. Same algebra, but now we're going to use or. And here's the best way I remember this. Here's my mnemonic, and I'm going to probably say this in class until you get sick of hearing it. Greater than is another way of saying more. More means or. And if you remember that, then you know the other one, which is less than, has to be and. That's my little mnemonic. More means or. So we've got the absolute value of 10x minus 2 is greater than or equal to 68. I already have my absolute value isolated, so I don't have to worry about what I did in the last example. I can start rewriting. So I'll drop my bars. Greater than or equal to 68. Just take the same problem without the absolute value. Then I stick my or in the middle. Second inequality, the left side is exactly the same, 10x minus 2. But now I flip my inequality symbol, and I stick a negative 68 in instead of positive 68. And then we do some algebra. So we'll add 2, divide 10. X is greater than or equal to 7. Add 2, divide 10. And this would be, I'll make it a decimal, negative 6.6. So x is greater than or equal to 7 or less than or equal to negative 6.6. And remember, the shading looks a little different for ors. It's going to shade out to the arrows this time. All right, one more. Now this is a mess because this absolute value is nowhere near isolated. So let's do kind of what we were doing before when we had absolute values in equations that were this messy. Let's get the part that I underlined, the 8 minus 5x, all by itself. Then we can rewrite. So we'll add 9 to both sides first. Okay, then we'll divide by negative 5. Ooh, now look what happened here. I'm dividing by a negative. I have to actually flip this. So guess what, ladies? This is actually not an or anymore. Because I flipped it. I made it less than. I actually have to rewrite it with an and. Okay? Be careful about that. It's only when you isolate the absolute value that you have to look and see whether you're using and or. So see how we started here and we thought this was going to be an or? Once we did our algebra to get this by itself, it turned into an and because it's less than. So we have and 8 minus 5x is greater than or equal to negative 2. Subtract 8. X is greater than or equal to 6/5. Subtract the 8 again. And careful, I'm dividing by negative 5, so I got to flip. I'm only subtracting 8. So I get negative 5x is greater than or equal to negative 10. Divide by negative 5. Again, I'm flipping, so it's now less than or equal to positive 2. Now I'll put my number line up here because I'm out of room on my slide. So we want everything greater than 6/5 or equal to 6/5, but also less than or equal to 2. So right in there, including the endpoints. Okay, you have some examples. Give them a try. We'll talk about them in class, and we'll do some more work with this. But otherwise, we're finished with Chapter 1. Have a good evening.